Well, good morning, everyone. Let's start level 2 NCEA for 2025. These are the exams that have just finished. Let's do a review. This is level 2 mathematics, applied probability methods and solving problems. So I'm just going to do this the first time. I haven't seen this before, and I'm going to use the Casio calculator that is by far the most common calculator that's going to be used. And if necessary, I'll just use the formula tables that are given to you. So let's jump straight in. Have a look at question one. Research has shown that people in New Zealand prefer having breakfast at cafes to having it at home. Good. One popular item on the menu is muffins. Good. The local cafe, Yarra's, makes muffins. Mean weight of 118 grams. Okay, so no mean. And standard deviation of 19. So you should be sort of noting mu is 118. The standard deviation is 19. It's in grams and grams, so good. Assume that the weights of the muffins can be approximately modelled by a normal distribution. So I should say for this, I'm going to use 440p as my basis for this. I think that's well and truly accurate enough. Okay, find the probability that a random chosen muffin weighs more than 100 grams. So we're wanting to find the probability that the X that we're looking for is greater than 100. So, and then if we wanted to draw a graph here, we can see that this is 118. So 100 must be about there, and we want that area there just to sort of get our head around what's going on. All right, what would we do? It's not the olden days, so we're going to grab a calculator. Let's go to stat mode, and we're going to go distribution, normal distribution. Now, do we want we do never want to use NPD. We want to use NCD and inverse 99% of the time. And let's put that we are given the end. So let's put in what we're looking for. So the lower end is 100 grams. The upper end, let's just put in something crazy like 300 grams. The standard deviation they give us is 19 grams, and the mean is 118 grams. If you have the update to these calculators, by the way, there is a screen which is much more user friendly on the later updates, but you can't get an emulator on the computer. So we'll just stick to this, and I think 95% of students are probably going to use this mode anyway. So let's do that, and we're going to send it in, and we get this. So let's work it out. So the probability is 0.82827 and dot dot dot. The low, so this is 0.94 standard deviations. This is the low Z score. This is the up Z score for the 300. 9 standard deviations away from the mean. What 9.5 is one in a trillion chance that something is going to be outside that. So putting in 300 was good. So the number we're looking for is this number here. So it's 0.828, and I said 4 decimal places. So let's round that up to 3. So our answer is going to be 0.828. 3. All right. Now it tells us what's the percentage of muffins that weigh between 100 grams and 120 grams. Let's X out of there, and now the lower is going to be 100 still, but now the upper is going to be 120. So if we were to draw this for this one here, so here's 118, here is 100 here, and here is 120 about there. We want that area there. We want that area there. Okay, grab the calculator, XE, let's enter, and it is 0.3702. Let's round it up. 0.3702. And they don't ask that though, they ask for percentage, and you should be able to do that at this age. It's going to be 37.02%, which you're going to say it's pretty much equivalent to 37%. Fair enough. Pretty standard questions. You should know how to get those numbers, extract them, whack them into the calculator, and get an answer. Moving along, now we're asked 10% of muffins are below the minimum weight requirement and cannot be sold. What is the maximum weight of a muffin that cannot be sold? Okay, so we have the same situation. So there is our mean of 118, and we want this area here to be 0.1, so 10%, and we want to know what's going to go there. So to do that, we've got the area. Now we want to find the endpoints. So we're going to use the inverse function. On the calculator, it's the same cinematic universe as before. So let's get out of there, get out of there. Annoyingly, you have to go back and forth. So here I've already set it up. So we want the tail to the left. The area that we want is 0.1. It has to be that sort of format there. And it comes pre-populated, so let's XE, and we get 93.6505. And it's grams, so we don't need to do anything to it. We don't need to sort of say that's a percentage. It's in grams. It's already in the form we want. So I guess if we wanted to round it to three significant figures, we go 93.7 grams. And that's that. I mean, it's just a matter of knowing what we've got. You should be asking yourself, are we using NCD or inverse? All right, the next question says that the capo wants to decrease the percentage of muffins that fall below the minimum weight requirement. They want to ensure that no more than 2% of muffins weigh less than 100 grams, while still maintaining mean weight of 118 grams. So I guess this is going to be our X, and this is going to come into play a little bit later on. And the mean weight is still going to be the same at 118. So they want to calculate a new standard deviation for the muffin weights that would ensure that no more than 2% of the muffins weigh less than 100 grams. So for this, we need to go to the formulae. We could use the tables here. When I was your age, we had no alternative but to use the tables. But I'm going to show you a kind of a cheat code workaround so we don't need to use these tables. All right, so what are we actually looking for here? So if this is 118 here, we want to find the z-score that would put this area here at 0.02. But we need to standardize it to use this formula here because we want to regard standard deviation. So we've got x as 100. Cool. We've got mu as 118. That's great. We don't know z, but we need to find it, and we are looking for that. Okay. We need to find z. So what we would do is we would say, okay, so the area that would meet this, we need this area here. This is why I don't like these tables for a lot of reasons. They're very finicky. We want the z-score that goes with particular that particular area there. We want it for that area there. What these give you is this area in black here. So the z-score we're going to get is going to be negative because it's to the left. This is a lot of stuff to remember, and it is a real pain in the neck. So we go into the tables here, and we find really, really close to what we want it of at 0.48. So we're going to come along here, and we're going to find until we go along till we find it. This one here is pretty close. So this one, that one there is pretty close. It's the one that's under it. So it's 2.0, 2.05, and then we want to add 2 to it. So we would say 4. The z-score would be there. That's just a not a great situation, and because it's to the left, it has to be negative. So rather than remembering all of this nonsense, let's just use our calculator, and I'll show you the workaround. So we want standard normal distribution. We want to standardize it. So I'm going to get out of there, and what I'm going to do, I'm going to reduce the area that I want here to 0.02. Okay, and then I'm going to change things around a bit. I'm going to set the standard deviation at 1 and the mean at 0, and that's going to give us the z-score. Okay, because remember, standard deviation, standard normal distribution is worked out when mu equals 0 and standard deviation is 1. And z is the number of standard deviations to the left or right that a number finds itself. I do a video on this, so I'm just going to do the question. Okay, I'm going to hit exit, enter, and hey presto, here we have the same number. Negative 2.05, and here we have it more precisely, 374, like that. I'm going to use, I think I'm just going to use this number because it's the same number to 3 decimal places. Okay, so we know that z is going to be minus 2.054. Now you had to have minus there, but if we had a positive, we're just going to get a screwy answer. Okay, now we've got everything. Now it's just an algebra problem. So negative 2.054 is going to be equal to x, which is 100 minus 118, which is the mu, divided by standard deviation, and we need to find the standard deviation. So using a bit of algebra, we can cross multiply that. So the standard deviation that we want is going to be 100 minus 118, which is obviously minus 18, divided by negative 2.054. And then we would grab our calculator again and find that. So let's exit out of here. Negative 118 divided by negative 2.054. Whoops. Now, delete that. Let's have time to go. So negative 18, not negative 118, divided by negative 2.054. And makes much more sense. So if our mean is 100 now, a standard deviation of 57, crazy. So our standard deviation is going to be 8.776. That's our answer. My advice would be only really use the tables in an emergency. It is just way too fiddly. You just have to remember so much nonsense. You have a supercomputer in your hand, so use it. I mean, you know, you can't get the right answer unless you know the theory behind it. So just use it. All right, now we're told that at Yaris, customers had to wait for their breakfast to be prepared. Okay, great. Graphs below show the time in minutes the customers had to wait. So this is Saturday and this is Sunday. All right, brilliant. What's the question? The question is the manager claims that less than one quarter of the customers had to wait more than 15 minutes for their breakfast on a Saturday. Use the graph to calculate the probability to support or reject the claim. Okay, so what we want, I guess, is the number of people who wait more than 15 minutes. 15 minutes divided by the total number of customers. So, and it's Saturday, they don't tell us how many customers there are. So I guess we're going to have to work that out for ourselves. And it is Saturday. So the number of customers that have to wait more than 15 minutes, it's going to be that. This is 15 minutes here. So let's grab our calculator and work that out first and then work out our net. 22 plus 15 plus 10 plus 8 plus 6 plus 2 is 62. So 62 there plus 18 for here plus 30 for here plus 50 for here plus 68 for here plus 90 plus 70 plus 30 plus 12, 430 in total. So 62 over 430. So put that in our calculator. Is that greater than or less than a quarter? So the 62 divided by 30 is, drum roll, 0.144, which is less than 0.25. So the manager's right. Okay. So compare and contrast the wait times on Saturday and Sunday. Discuss shape, center, and spread in relation to the contents. So we want to compare these two graphs. Let's make it a little bit smaller. Let's rub out all of this. And let's make them a little bit smaller. So here's Saturday. Saturday up here. This is a Sunday. So this is how it's given to you in the. So what do we notice is the difference? Well, we notice that it seems to be on a Saturday, it seems to be skewed to the right. So it's almost like a Weeble distribution. So it kind of goes like that. So it skews off to the right slightly, whereas this one is almost it's almost Bellevue. There is this little blip here. All right, that's fair enough. There is a sort of a little blip here as well. So we have to wonder whether they're unimodal or bimodal. Probably unimodal. This is not much of an issue. Unless you're this poor customer here has to wait over 20 minutes for a cup of coffee. Um, the spread, gee, this is Sunday is a lot. The spread is not a lot, but the spread is a little smaller. It's more symmetrical, and the mean and the mode and the median are pretty much in the same place. So it's apart from this little blip here, it is kind of almost normally distributed. It is almost like a bell shape, and this is it's the Weeble shape, skewed out to the right. Um, there seems to be like a whole bunch really tightly packed here, but it skews. So it's an interesting question. There's obviously a difference, and any of those answers would be the same. The mean is obviously lower here. It's a whole 2 minutes lower, and there are less numbers here by the looks of it on a Saturday than a Sunday. So this is a bigger total. This is 430. I don't know how many this would be. It's probably be a bit more, say 500 odd. Something just text me. Yeah, okay. All right. Question 2. Yaris did a survey to determine which breakfast option is preferred by their customers. Their main choices were muesli, pancakes, or bacon and eggs. They then had a choice of fresh fruit or yogurt. Okay, 25%, blah, blah, blah. Draw a probability tree and use it to answer the parts below. Okay, so the first choice they've got is whether they want muesli, yeah, pancakes, or bacon and egg. Bacon and egg. Uh, then they had a choice of fresh fruit or yogurt. Fruit, yogurt, fruit, yogurt, fruit, yogurt. Okay, so then let's put in the numbers. So 25% of customers chose muesli. I'm going to put these in as decimal fractions so I can multiply them through a bit later on. So 25% is 0.25. 30% chose pancakes, so 0.30. And then that's 0.55. So the rest chose bacon and eggs. So that's going to be 0.45. Okay, then they tell us that 2/5 of customers preferred fruit with their muesli. It's not really that well worded. So 2/5 is 0.4, so this must be 0.6. 18% preferred yogurt with the pancakes. So that's 0.18. This must be 0.82. Customers who chose bacon and eggs were equally likely fruit or yogurt. 0.5 and 0.5. And then we can multiply down if we want to. But let's go to the question. What is the probability that a customer chooses pancakes and fruit in their breakfast? So the probability of pancakes and fruit. So I guess they mean a customer chosen at random. So pancakes is 0.3, and we multiply down the branches and add between the branches, and fruit times 0.82. And it's going to be a number. So 0.3 times 0.82 is 0.246. Okay. So for a randomly selected group of 250 customers, how many customers would you expect to choose yogurt? Okay, so there are three ways they can choose yogurt: this way, and this way. We have to work out the probability of both. So the expected value, so the probability of the expected value that something happens is the probability that that happens in one trial times the number of trials. So the probability of yogurt we can work out. So it's going to be 0.25 times 0.6. For the muesli, plus 0.3 times 0.18 for the yogurt, for the pancakes, sorry, and then for the bacon and eggs, it's going to be 0.45 times 0.5. And it's going to be a number. So let's grab a calculator and work it out. Plus 3 times 0.8 plus 0.5 times 0.5 equals 0.429. 0.429. Okay, so we've got this bit. Now we need to multiply that. But then 0.429 times 250 trials. And it's going to be a number. Love me a number. Times that by 250 is 107.25. Okay, now you could leave it like that. You'd probably be better because we're dealing with people. To round it down to a whole person, you can't have a quarter of the person walk into a cafe. Yeah, they tend to not really appreciate that. It leaves quite a mess. Right, next question. The cafe is running a loyalty promotion each month where customers who spend over $100 at the cafe will go into a draw to win a prize. Each month, 35% of customers spend over $100, 1/5 who spend over 100 win a prize. 40% receive a $20 discount voucher, and the others receive a free coffee. What a scummy prize thing. Okay, so let's uh, let's do that. So we have over $100 here, and we have under $100 here. Okay, so 35% of all customers, so 0.35, so this must be 0.65, and 1/5 of those win a prize. So a tiny, tiny number. Let's say win, and let's say this is lose. So 0.2, 1/5 of 0.2. So that must mean that 80% don't win. Of the prize winners, 40% receive a discount, and free coffee. So even if you do win, you win a pretty scummy prize as well. So 0. So you've got to buy something anyway. Okay, and then so that means that 60% receive a free coffee. Wow, spend $100 and you may win a coffee. Okay, so what proportion of the cafe's customers do not win? We could argue that none of them really win, but let's work it out. So these people who spend under 100 do not win. So that's 0.65 they kick off. So then we need this one here. And remember, we multiply down the branches, so it's going to be 0.35 times 0.8. It's going to be in that one, and these ones, technically, I guess they are winners, but we're not really interested in them yet. So 0.65 plus 0.35 times 0.8. So 0.93. So 93% of the customers were nothing. No soup for you. Well, no coffee for you. Now they want to know, what is the probability that a customer who spends $100 next month wins a free coffee? All right, so we're saying, what's the probability if they win a coffee given the fact they've already spent over 100? So if you can think about it in our tree, we're sort of starting here, aren't we? So they win a free coffee, so it's going to be 0.2 times 0.6, which is 0.12. There we go. I think that's probably all the working you need, because in order to get those numbers, you had to do the work. All right, the next question, I think it's a bit of a trick question. The customers who spent over $100 but do not win a free coffee can now win one of two consolation prizes: a badge or a sticker. No, it's not a trick question. Here we go. So the probability of a random customer winning a badge is 0.21. All right, so this is our end probability they're giving us, 0.21. What is the probability of a customer winning a sticker given that they have won a consolation prize? What a strange one. Okay, let me think through this question. Probability of a random customer winning a badge is 0.21. What is the probability of a customer winning a sticker? Okay, so that tells us that if they lose here, they get to win either a sticker or a badge. And then they tell us that the probability that they win a badge, any customer random winning a badge, is 0.21. So the end probability here is 0.21. So we need to know these probabilities here. So I'm going to call this, let's just call this A, and let's call this B. So A is going to be probability that when we multiply down one of these branches, we get 0.21. And when we find this, we can find B. And B is what we actually really want to find. Okay, so if we multiply down the branches here, so let's kind of do this here. So 0.35 times 0.8 times A equals 0.21. Because we multiply down the branches and we get 0.21. So now it's an algebra question, which is good. So 0.35 times 0.8 equals 0.28. So 0.28 equals 0.21. So therefore, A must be equal to 0.21 over 0.28. Follow the logic? So 0.21 8 is that. So 75%. 75%. So therefore, if this is 0.75, this must be 0.25. We're going to presume that everyone who loses gets a consolation prize. That's not really clearly spelled out here in the question. It's not a really well-worded question, to be honest. So the answer is 0.25. Okay, let's move on. And last, question 3. So the cafe records show the following information for customers based on the most popular coffee selections. What percentage of customers ordered a cappuccino? So we're dealing with all customers with the cappuccino. So it's going to be out of 650, 125 out of those 650 is going to be cappuccinos. And they want it as a percentage. So 125 over 650 is going to be some of that. So let's say 19.2%. Could round it down to 19%. It's up to you. Okay, now we're asked, what is the probability that a randomly selected teenager wants a latte? So let's put it in proper notation, that they have a latte given the fact that they're a teenager. So it's going to be out of all the teenagers, how many teenagers are there? There's 280 of these kids in the cafe, and 184 of those 280 have a latte. Latte and a plum Danish. One of my friends is going to get that joke. Latte and a plum Danish, thanks. Okay, it's 65.7%. So 0.657. So it's 3 dp. Well, almost 2/3. So now we want probability that a randomly selected customer, so this is out of all of the customers, all 600 customers, is either an adult or a cappuccino drinker. So how many meet that criteria? So there are 350 adults, 350, what am I saying? 370 adults. And then we're going to need to find how many teens are cappuccino drinkers, and there are 20 of those. We're not going to count this because we've already counted them. So that's going to be 390 divided by 650. You know the drill. Outcomes calculator. Oh, 0.6. Right, next question. From the data, the owner believes that it is twice as likely for an adult than a teenager to order a mocha. His manager thinks he is wrong. Explains why the owner believes this. So let's have a look at the information. So from this, we can see that of all the mocha drinkers, probably, okay, so 76, 150. So there are 76 teen mocha drinkers. Mocha, and 150 adult. I think there's an extra mocha drinkers. So, of all the mocha drinkers, about 2/3 of them are adults. So, there are 76 plus 150. There are 226 mocha drinkers. 150 divided by 226. So 2/3 of those are adults. But that's not really fair because we need to deal with the number of we need to work out the probability that they're a mocha drinker given their teen versus the probability that they're a mocha drinker given that they're an adult. And it's not going to be the same. So 150 76 times 2 is going to be 152, which is almost 150. So that's why he's wrong. So your answer would be a bit more specific than I think. Yeah. All right. Next question is they pretty much want you to do what I thought they might want to do. So I've cut and pasted the table. So show with appropriate calculations how the manager can prove that the owner is wrong. All right, so whether that's a good idea or not, to get on the bad side of the owner, okay. So we want to work out the probability, don't we, that you have a mocker given the fact that you're a teenager. So that's going to be the number of teens who are with the mocker. And that's going to be what's the total number of teens. Yeah. So that's going to be 76 over 280. That's going to be as a decimal fraction. Right. 0.27. 0.2714. All right. Now, the probability that you're a mocha drinker when you're an adult, and that's going to be equal to the number of adults who drink a mocha over the number of adults. So that's going to be just looking at that 150 over 370. So it's going to be 150 over 370. 70 is 0.4054. Okay, now we are sort of there. This really is a relative risk problem. So the relative risk, I guess the relative risk of being a mocha drinker is going to be the percentage of mocha drinkers given that you're an adult, which we've worked out, yeah, divided by the probability that you're a mocha drinker given you're a teen, which we worked out up here. And that's going to be 0.4054 over 0.27114. Let's grab our calculator. I love using the calculator. 0.4054 divided by 0.2714. So 1.4. So 1.4937. Okay. So yeah, adults are let's say 1.5 times more likely, but they're not 2 times more likely, or some variation of that. Right, the last question. I hope, I think. Research shows that there is a strong link between coffee consumption and anxiety in both adults and teenagers. Some findings suggest there is a greater impact of coffee on teenagers' anxiety than on adults. The table shows some of these findings. Uh, so research claims that teens are 80% more likely to be affected by anxiety than adults. Complete the table and evaluate this claim using calculations and data and interpret these in context. So I guess the first thing we need to do is complete this table. So in here should be 347 minus 267 should be 80 in here. So 80 plus 130 is 210. And in here, this is going to be 600 minus. Oops, what's it? Oops, leaked up to 210, and we need to bring the calculator. So in here, it's going to be 600 minus that. Why they do this, I don't know. 253. That is kind of childish, these questions. And 253 minus 130 is 123. I don't know what that accomplishes, but doing that, it's not really that amazing. All right, so how are we going to do this last project? All right, well, the first thing we're going to need to is we're going to need to work out the risks. Let's do a relative risk analysis. So, what's the probability that someone has anxiety given that they're a teen? So that is going to be 267 over number of teens is 390. Is 0.6846. Really, really high. 70% of teenagers have anxiety. All right. So there is a problem here if you're really doing statistics. You need to say, okay, is this anxiety really being induced by the coffee, or is there some other underlying problem that's not being picked up? Is this a false variable? So then we would need to say, what's the probability of having anxiety given the fact that they're adults? So that's going to be, put this down here, that's going to be equal to the number with anxiety that are adults, given the number of adults. So that's going to be 80 over 210. So that's 0.3809. So it's going to be 3809. Okay, so we see that there is a different rate here. There is a different relative rate risk. So now, and it is greater in teenagers. So that's good for a start. Now we need to evaluate this claim that there's 80% more likely. So the relative risk is going to be the probability uh, of anxiety given adults, anxiety over children is not children. I know you hate being called children. Teens have a probability of anxiety given the fact that they're adults. Okay, so that's going to be 0.6846 over 0.3809. Let's work that out. Which can hear is the Trash man coming. Whoops, forgot decimal place. 0.6. 17,000 times like. Okay, 0.6846 divided by 0.3809 is 1.797, which is pretty close to 1.8 or 80% more. So the claim is valid given the data that we have. So we're going to presume that this data is good data. I would sort of want to say, okay, probably really make that big leap. Is all this anxiety induced from coffee? Is there something else that teenagers are just more likely to get anxiety than adults, regardless of whether there's coffee involved? But we don't have enough information. So, given the information that we've got, the data is fairly kosher. Can we put anything else in here? No, that's pretty much it. That's the end of the exam. So a pretty good exam. I really hope they get rid of these questions. They're just so silly. They don't test your ability to interpret statistics. Um, some of them are really, really good. I mean, the questions are fairly standard. And this is a fairly standard exam, probably a little bit along the easier end. But okay, pretty good. Okay. All right. Have a good day.